Welcome to this new series from game developers geared toward a new 3D game engine, FLAX game engine. In this video, we are going to continue with the implementation of the player controller, and in this case, controlling the jump as to allow only one jump, a basic camera follow, and then starting to introduce the animations to explore the possibilities of the engine when dealing with it. As within the first video, we are going to blend C# and visual scripting. First, as always in our channel, let's see what we have up to now. Not yet very much, as we were only able to move through the world and jump an infinite number of times. So, we have a lot of things to do. Let's jump into the actual tutorial. The first thing that we have to do is to fix a problem that we had with the references in the visual script parameters, where we were constantly losing the references to the rigid body. The problem is caused by trying to set the reference from the visual scripting editor and from the game inspector at the same time. It is better to use only the game inspector one. So, for this, let's clear both references in both systems, and then add again the reference to the player rigid body from the game inspector, and you should have no longer any problem. Let's start now by implementing a basic camera follow, as to be able to see with more detail what the player character will do. For this, under the source and game folder, create a new C# script and name it camera follow. Double-click to edit. Let's start by creating some public variables to control the overall behavior of the script, a target to follow, and a target offset which will hold the distance at which the camera will follow the target. Since the target will hold the player object reference, we need to define it as an actor, which is the equivalent of a game object in Unity. All the code will be set on the onUpdate function. First thing, let's check that we have a target to follow before making the calculations. Then we update the position of the camera through the actor position to a linear interpolation, vector 3 lerp, between the current position of the camera and the target position adjusted with the offset. The last parameter is the speed at which we want the adjustment to happen, in our case 0.1. Last, we want to have the camera looking at the target by using the lookAt method in the actor class, which receives as a parameter the position where to look at. And we have finished. Let's go back to the scene view, and drag the camera follow script to the camera. Adjust the offsets of the camera, in our case 500 in Y and 2000 in Z. Remember that in FLAX engine the units are in centimeters. Then drag the player object to the target slot. Let's run the game. And we see the camera moving away from the target. That is not exactly what we wanted. Let's check the code. Okay, we have made a slight mistake. We have added the actor position instead of the target position. If you have made the same mistake, replace it with the target position, and save the code. Run the game. Now, the camera correctly sets itself at the offset distance from the player and looking slightly down. Time to correct the jump function, which is not checking if on the ground before jumping, and which enables an infinite number of jumps. For this, under the player, let's create an empty actor, by right-clicking on the player and then selecting the new actor. Rename it to ground check, as we will be using it to place where to check for the ground. Move the actor to -50, which will place it at the bottom of the cube that we are currently using to represent the player. If you remember, the jumping function was being managed by a visual script named jump. So, in the content folder, double-click on the jump visual script. In the visual script editor, let's add some parameters that we will need for the script. Create them in the same order as us, as there is a bug in the system, and as soon as you create an unsigned integer, the button to add parameters will disappear and the editor will start to have strange behavior. First, let's add an actor parameter and name it ground check. We will use to receive the position where to check for the ground. Then, create a Boolean parameter name as grounded. We are going to use it only for visual debugging and checking if the code is correctly detecting the ground. Let's create a new function where we are going to check for the ground. So click on the plus sign in the functions bar. In the new dialog box, rename it to check as grounded. In the return type field select bool, as the function will return true or false to depict if grounded or not. We can see that two new nodes are created, one for the function and a second for the return. Let's drag the ground check parameter to the canvas. And, from the exit point, drag a new connection to the canvas. In the node selection window, select the function getPosition. Click on the editor, and in the node selection, type check sphere. Select the function under the physics category. A new node will appear for the function. Drag the output of the getPosition node into the position entry of the check sphere, and then connect the flow arrows from the check as grounded entry to the check sphere into the return node, to make sure that the execution flow is completed. Connect the return exit of the check sphere node to the return node. Let's create more parameters. First, a float radius, that will set the radius of the sphere cast. Drag it to the canvas and connect it to the entry radius of check sphere. And finally, the unsigned int mask to hold the layer mask against which we want to check the collision. You can see that as soon as we create it, the visual editor loses the properties pane. You have to resize it to make it appear again. You can also check that the button add parameter has disappeared. Let's drag the mask parameter to the canvas and connect it to the layer mask entry in the check sphere. Before finishing the function, create a new node of type setParameter. Select the as grounded parameter in the select field and insert it between the check sphere and the return node. Now, let's go to the onUpdate function and create a new node. In the node selection, type the name of the function just created. In our case, check is grounded. Right-click on the node and select the option to convert to method call. Connect the onUpdate execution flow to the new function. Create a new node, and select the Boolean AND. Click the exit of the check is grounded function to the A entry and connect the exit of the get key down to the B entry. Then connect the output of the AND node to the entry of the if node, and the execution flow of the node check is grounded to the execution flow in the if node. Save and exit the Visual script. For the code to run, we need to set correctly the ground object to a specific layer. If you select it and check in the Inspector the Layer field, you will see that we have the default layers. To create a new layer, we have to go to the Settings folder under Content. In the listing, we will find an option named Layers and Tag Settings. Double-click to open. In a free slot, type the new layer that you want to create. Take note of the index position where it is created, as you will need this number to pass the correct reference to the function. In our case, you can see that it is saved under the element 3 slot. So our index is 3. Save and close. For the new layer to appear, you need to close the project and reopen it. So let's do this before continuing. So, we have closed and reopened the project. If you select the ground and go to the layer property, you can see that now we can choose the layer ground. Let's go back to the player, and let's set the parameters for the jump function. 0.01 for the radius. In the mask, we need to pass 2 powered to the index of the layer that we have created. So in our case 8. Let's drag the ground check actor to its slot. Save and run. We can see that as soon as the player touches the ground, the parameter is grounded as checked, meaning that the object is grounded. If we jump, the parameter unchecks, and we are not able to jump again, until we have landed again. So the jump function is working correctly. Let's address now the animations. The animations in FLAX engine are slightly more complex than in other engines and have more elements to be taken into account to be able to work correctly. The first thing is that we need to add an animated model to the player. It can be found in the toolbox under the Others option. If we look at the properties of the animated model, we can see that it takes two main elements to work. A skinned mesh for the model to be displayed. An animated graph is where we control the animations. So let's start to import a character. We are going to use a model that we have downloaded from CG Trader, and for which the link will be in the description. The first thing to do is to duplicate the FBX of the mesh. We are going to use one to be imported as the skinned mesh, and the other one to import the animations. Let's create a folder. We named our character Monster because it is a monster. Right-click in the content browser, and select the option Import File. Locate the FBX file that you are going to use as the custom mesh and import it. The Import Settings dialog box will open to allow you to set correctly the importation. First thing is to change the type option to Skinned Mesh. Then check the Calculate Normals and the Import Blend Shapes. In our case, we will set the scale to 2 to have a bigger model. Click the Import button. And you will see that a new file is visible on the content browser. This is our Skinned Mesh. We can drag it to the skinned mesh slot on the animated model object that we just added to our player. Immediately, you will see the new character on the screen without any texture or effect. Let's try to apply the textures, so we will need the textures of the character. For this, right-click on the content browser and select Import Files. Select the textures for your character. This will prompt you again with the import settings, in this case for the textures and normal maps. You can go with the default options that will work correctly. Create a new material by right-click on the content browser and New option. Name it Monster Material. Double-click to edit. Create a new node of type texture. Drag to the texture field the character texture and then connect the output color to the material color entry. Create a new node of type normal map. And drag the normal map from the character into the normal texture and connect its vector exit into the normal entry of the material. Save and exit. Drag the new material into the material slot of the animated model. We can see that our character is now correctly colored. We have some lighting issues that we will deal with later on. Let's import now the animations. In our case, all the animations are embedded in the main FPX file, so we will have to import at least one time the file, and then duplicate it internally to create the different references to each of the animations. But, we have had to start with two copies of the file, one for the custom mesh and one for the animations. So, right-click on the content browser and select the import option. Select the copy of the file that we made earlier on. In the import setting, in the type field, select the animation option. Check the calculate normals. We will set the scale to 2, as we used in the previous import. Scroll down in the options. You will see that there are animation parameters. If you know the index of the animations in the file, type it. In our case, we are going to use the idle, which is the animation index 4. Click Import to finish. We will get another icon on the content browser with the name of the animation. The icon is black. Let's check if the import has worked correctly. Right-click again on the content browser, and select New Animation Graph. We will rename it to Monster Animation Graph. But you can use any name you wish. Double-click to edit. A new visual editor window will pop up with only an animation output node. Let's drag our idle animation into the canvas. A new node will be created with the name of the animation. In the right pane, we can see that the system is asking us for the skin mesh of the character, so drag into it our character mesh. Link the execution flow output to the execution entry on the animation output. As soon as we connect both, we can see that the preview window will show our character animated with the idle animation. Save and exit. Right-click on the idle animation and select the duplicate option. Rename it to Monster Walk or any other name depending on your case. Double-click on the animation. A new window will appear to allow you to change the overall parameters of your animation. You can perform a lot of different actions, but in our case, we are only interested in changing the animation index under animation. Again, in our case, the walking animation is the second animation on our file, so we'll use the number 2 as the animation index. Click the option Re-import to make the modifications. Let's reopen the animation graph. And replace the idle animation for the walking on, as to make sure that it is working. We can see that it is working correctly. Delete the walking animation node. We are going to start to address the state machines that will allow us to control the overall animations. So, right-click on the canvas, and choose the node selector state machine. It will create a new locomotion node. You can change the name if you want. But, we will go with the default naming. Connect the locomotion and animation output nodes. Then, in the locomotion node click on the edit button. A new blank canvas will appear with only one state called entry. Right-click and create a new state, name it idle. Repeat the operation and create a new state walk. Select entry and link it to idle. This will make the idle to be played by default. Then select idle and connect it to walk. Select walk and connect it back to idle. Let's now associate each state with its correct animation. Double-click on idle. Drag into the canvas the idle animation and connect it to the state output. Save it. On the top bar of the window, you can see to the right, that we have a breadcrumb menu, to map where we are making our modifications. Click on locomotion to go back to the locomotion state. Double-click on walking and repeat the steps to add the walking animation. Go back to the locomotion state. We need now to control how we will be moving between animations. For now, and in our case, we will need only one parameter to control it. So, in the right pane, click on the button Add Parameter of type bool, and name it as walking. Let's now add the control code to the transitions. So, double-click on the transition walk to idle. Let's drag the parameter as walking into the canvas. Drag a link from the created node into the canvas, and in the node, the selection chose the Boolean not and link it into the rule output. We are saying that when is walking is false, we will go into the idle. Go back to the locomotion and double-click on the transition idle to walk. Drag the is walking into the canvas and connect it to the rule output. This means that when is walking is true we will go into the walk state and run the walking animation. If we go back to the animation graph beginning and run the game, by checking or unchecking the is walking parameter we can check with the state machine is working correctly and shifting the animations as expected. Before running the game, let's implement the C# code. Let's go to the player script. Before the animation part, let's modify the movement. In the last video, we used force jump for both the jump and the movement. So let's add a new float variable to hold the force move, and then replace it in the onUpdate method. Now, let's define an anim graph parameter anim walking that will hold the reference to our is walking parameter in the animation graph. On the onStart method, let's grab the reference to the parameter on the animation graph. Since our animated model is a child to the actor where the player script is located, we need to get it through a getChild for the animated model class, and finally getting the parameter reference to is walking. Let's set the initial value to false, to make sure that we start in the idle state. On the onUpdate method, let's set the value of the parameter to true in the condition where we are moving. And if not moving, let's set the value to false. Save and go back to the scene view. Before running the game, we need to associate the animation graph with the animated model, by dragging it into the animation graph slot. We need to perform some more adjustments to the animated model. The first one, is we need to rotate the animated model around 30 degrees in the x-axis because the animation is rotating it for an unknown reason. Then we have to decrease the Y position to make his feet to get in contact with the ground. Finally, let's adjust the sky lighting, which is the ambient light, to have more ambient light to be able to see better the character. Let's run and we have an animated character on the screen. Let's finish now. In the next episode, we will keep improving the character controller to include orientation based on the inputs, as well as adding more animations. We hope that you have liked this video. If it has been the case, consider subscribing, giving a like, and clicking on the notification button. If you have any questions, problems, or comments, don't hesitate in putting a comment and we will answer as fast as we could. See you in the next video, game developers.